I'm going to spend a few minutes talking about the digital twin. The interesting thing about twins, they can seem identical almost every way. But really, there is no such thing as a 100% identical twin. In fact, they can look identical and act totally different. And so, why do I talk about twins in this way? When you think about the digital twin, the value of the digital twin is how closely the digital twin can represent the physical product or the factory, the production of that product. That's the value. And sometimes, a lot of people still rolling in, it looks like. Sometimes the value of the twin is not always so good because the twins aren't that close to each other. And what we're seeing in our industry is, I see very large manufacturing companies talk about digital twin, and at best, they might be able to represent a little bit of what's happening in the factory. No idea how to design the product, no idea how to do the manufacturing execution of that product, right? Or you see a CAE company talk about digital twin, and the best they can do is analytics on the part, maybe. No idea how to produce it, no idea how to design it. So really, is there a lot of value in that digital twin if it's set up that way, that you're not really representing the full digital twin of the product? And why is this important? When we talk to customers, the fear is disruption, right? There's always somebody in the wings waiting to disrupt you. And after all, everybody and their brother wants to build an electric vehicle today. You got Google and thermostats. I mean, who would have thought? So you don't know where your next disruption is coming from. And there's really only two ways to respond. You either be the disruptor, or if somebody disrupts your business, you better be able to respond very, very quickly to that disruption. And this is one of the reasons there's such an interest in this idea of digitalization. Because it's the backbone that allows you to be able to make decisions quicker, to be able to do the things you need to do, to either be the disruptor or, again, respond very, very quickly. The other part of it is there's a number of enabling technologies that are changing the way you think about the digital twin and things you can leverage. So, for example, in the idea of the area where products come to life, generative design. I'll speak about that in a moment, about what we're doing there. Intelligent models, smart products, software, mechanical, all coming together, electronics. And then what do you do with a systems of systems approach, which we've talked to you about before in our strategy. Change the way products are realized. We'll talk about additive manufacturing and what it means. Advanced robotics, machine learning, all of these new enabling technologies that are really changing the way you think about how you come to market with products. And then finally, the way the products evolve. What's happening with the product in the field? What am I learning from that, and how is it influencing the way I go about my R&D process with the products that I design and work with? These are all enabling technologies that really change the way you think about this. So some of you have seen this before. When we talk about it in three phases. Ideation, realization, utilization. Ideation is that upfront phase of design, R&D. Utilization is the feedback loop. Again, what's happening in the field with the product? How do I bring it back? How do I change the way I think about how I'm designing the product? How do I leverage the data that's there? There's lots of people that can do that or talk about that. But many of them miss the middle part. Somebody's got to make it and build it. And this is where we think the real value of Siemens is. Not only do we cover all three, but we also produce products, and we make things, and we use our own software to do that, and we learn a lot from doing that. And so, as we add more and more detail, the fidelity of these models, they start getting smarter, and they better represent that physical twin as we start to build out the products that we have. So, how do we add that detail? How do we create the smarter digital twins? Well, part of it is having a broad portfolio. I'll talk a little bit about the portfolio that we have. We have this digital enterprise suite that really is kind of 9 different segment areas we talk to. One is the obvious area of product design with our CAD solutions that we have in place today. Electronics and software, I'll talk about that a little bit more later. Predictive analytics, what we do in manufacturing engineering, the tools you're familiar with that we have with Technomatics and so forth. Our performance analytics, the feedback loop from service and service lifecycle management. Factory automation, the strength of what Siemens is known for many, many years. And then what we do with manufacturing execution and how do we bring that all together in a collaborative environment. These are the components that make up what we talk about when we think of Digital Enterprise Suite. And our strategy, if you've listened to us over the last few years, has all been around doing that. How do we better represent that digital twin holistically? We've made a number of investments to get there, a lot of investments. We've spent $6.5 billion since 2013. Really to grow out the portfolio, to be able to better represent this. You know, it started, frankly, 10 years ago in Siemens with the acquisition of all of us with UGS. And then from that, we've been building out over time. And you know, many of these you know with what we've done with Vistagy, with composites, and how we brought LMS in for 1D, 3D, physical test. CD Adapco from the most recent meeting a year ago has been an acquisition for computational fluid dynamics, and I'll talk a little bit about what we're doing there. Polarian for application lifecycle management, software development process. And then across the top, when you look at production engineering and execution systems, what we've done with CamStar for MES, Preactor, some of the others that we've acquired in this space, IBS for quality management. And then there's another one on the top with Bentley Systems, not an acquisition, but where we're working together with Bentley, where we've invested together with Bentley to actually not only build out the digital twin of what's happening with, again, the product and the factory, but the plant. And how do we represent the plant and the design of the plant? All of those pieces we see as components to better represent that digital twin. So, the most recent acquisition, Mentor Graphics. I think most of you are familiar with the proliferation of electronics and integrated circuits really in every aspect of everything we work with today, right? So with all of that increased importance of those areas, really we had to look at how do we better round that out in our portfolio to represent, again, the digital twin. So it's all about the importance of IC design, the printed circuit board, the overall packaging, the simulation. How do we integrate all those pieces together? And with Mentor Graphics now, we have the most comprehensive suite of tools to really design and manufacture the next generation of complex products that are being brought to the marketplace. That's what Mentor is all about. Bring best-in-class EDA tools from PCB design to manufacturing to execution of the manufacturing. The most advanced PCB analytics tools that are in place for analysis, for verification. And even with the capital platform, or capital solution set, designing platforms, autonomous vehicles right now, one of the big issues with autonomous vehicle is the amount of data that's being pumped through the architecture that's put into a vehicle. You got ECUs, the sensors, how you're moving all this data. This is what Mentor brings to us, defining that architecture for what we're doing in many of the industries that we're in. But it's also about the integrated circuit business. The gold standard for integrated circuit is Caliber for design and verification. This is a tool almost everyone uses to prove out this solution set. Now it's a little bit different. We talk about systems. In the previous example, we're talking about a printed circuit board, and you would probably maybe change the design of the board. You might do something different for packaging or whatever. With an integrated circuit, obviously you probably wouldn't do that. The circuit will pop in. But you still want to be able to simulate it in the overall solution set. There's other things we're looking at about what it means to manage requirements and data in this space. But aside from that, the integrated circuit business on its own is a rapidly growing business. And the reason it's growing rapidly is you've got new entries into the space, people that traditionally would have never built an IC before. People like Facebook, Google, Apple, Huawei, others are all saying, look, we're going to start building our own ICs because of the embedded system on a chip that we want to put into our solution set. So again, a very, very rapidly growing space for us. Over the years, dealing with many of you, with many customers I've talked to, we used to get a lot of requests. I need you to integrate NX and Team Center. with Mentor Capital Harness. What are you doing? And we've done some work there. Today with NX11, you can do cross-probing. You can understand, how this relationship works. What you'll see, though, with NX12 is completely embedded systems, completely integrated together, right, in how we go to market and how we work together with our solution sets. So after me is Martin O'Brien will be on stage to talk a little bit about, and Martin's the Vice President and General Manager of Mentor's Integrated Electronic Systems Division. He'll talk a little bit more about that as we go forward. So when you think about the solution set and how it's used, we have customers like Maserati, for example. Maserati wanted to increase their capacity while still keeping the traditional image of exclusivity with their product, right? So they came to us and said, look, what can you do for us? We equipped everything about their go-to-market, from the design to the factory, all of it working with Siemens technology. And what we were able to do was really shorten their time to market by 30%. I'm sorry, 30% reduction in R&D time, but overall reduction in time to market from 30 to 16 months. And at the same time, increase the output of their vehicle production by 3x, where they are today. There's many stories like that in this room, 30, 40% increase in productivity. And we've talked about, those are big numbers. But my question is it big enough? And really what we're saying is, do we need to dream bigger in how we think about this? Why can't we be 200 times faster rather than 30%? What are the things we can do to allow you to be 200-300 times faster with the solution set? And that's what I challenge our team with every day. What are the things that we can do to really help our customers get to that level? I'll give you some examples of this as we go through. First of all, in this ideation phase, talk about, again, systems of systems, complex products, electronics, software, mechanical, all coming together. How do you simulate this? How do you really manage it? A product like this, like an automobile's got 30, 40,000 requirements. Requirements that are ranging from environmental requirements to performance and handling requirements, reliability requirements. When you make a decision in one part of the system, you have no idea how it's affecting the rest of the system. You need some kind of a backbone to be able to do this. So you can make decisions with confidence. So you know the trade-off versus this continuous cycle of making changes based on requirements and not knowing the impact from one to the other. So what we've done over the last few years is really the acquisitions that we've brought in are helping us to round out this systems of systems approach. Right? It's everything from LMS coming in and helping us with simulation of suspension, noise cancellation. The Mentor piece I've already talked about, Polarian for application lifecycle management. All of these components, coupled with the work that we've already done with Team Center, with our CAD tools and so forth, really put us in a unique position to be able to make decisions very quickly. Suddenly, it's not 20, 30%, it's making decisions a lot quicker than your competition in how you work. In the area of CAE, we've made a number of investments here as well, and that is, first of all, as I spoke about with LMS. Why is that important? This predictive engineering analytics, you gotta have it to be able to understand what's gonna happen with that digital twin, right? So it's investments in what do we do with 1D and 3D analysis? How do we combine what we already had with NX CAE within the solution set? And then with CD Adapco, computational fluid dynamics coming in play. I'll talk a little bit about what we're doing with HEEDS as well in a moment. All of those pieces we brought together into SimCenter. I think the other interesting thing about this is, when you're thinking about CAE in a traditional world of where we are today, we have proven solutions that allow us to analyze and understand what's happening with the design of a product. But think about where we're going with additive manufacturing. You're pushing the edge now, new materials, lattice capabilities, all of these things. These are unproven, uncharted territories for us. There's no one that's gotten models that have proven that out completely. The really cool thing about LMS is we still have physical test capabilities with LMS. We can use the physical test to further refine the algorithms and the software we have for the digital verification of those leading edge technologies. Very important differentiator in the marketplace. Some of you have heard this story before, but I like it, so I'm going to tell it again. And that is an example of thinking differently. FMC is a user of our NX software. They were also a customer of CD Adapco for fluid dynamics. And their challenge is undersea piping equipment. And they were designing a control valve. The trade-off was flow rate, pressure drop, and erosion. Right? The faster the flow rate, or faster the pressure drop in the piping, faster the flow rate. Too fast of a flow rate was causing erosion in the equipment and so forth. So they had a trade-off, right? How do you make it? How do you design it to get the max without having this erosion, right? And so they coupled this with HEADS. HEADS is a design optimization tool that came along with CD Adapco. We acquired a CD Adapco. Prior to this, doing the design verification and trying to make this work, they could do 3 iterations in 10 days. 3 iterations in 10 days. Putting HEADS on top, they did 300 iterations in 5 days. So how long do you think it is? How long do you think it is before you're disrupted when your competitor down the street's doing something 200 times faster than you are? And that's what we're talking about when we talk about thinking big. It's thinking about things differently. It's not about best practice, it's about the next practice. What is the next way to do something? In this case, it's using a HEADS tool that just does design optimization. It's not talking about overall systems engineering and all the things. Design optimization for a part design, 200 times faster. They have other examples. They have an example in robotics where they were using a nonlinear transmission joint. Really, it was a robotic arm. Decreased the power consumption, improved the manipulation of the robotic arm, and improved the payload performance of that arm. HEADS found the optimal design after 115 evaluations. Again, very quickly, 115 evaluations and found, hey, here's the design based on this. And again, the competition's iterating 2 or 3 designs at a time. We just did 115, proving out where we're at, right? And so these are things we're talking about when we talk about 200, 300 times faster in the process. In the area of realization, most of you are aware of additive manufacturing, I think. And I guess what I'd say is, anybody can model a part and print it. That's not really what additive's about. That's where it started. What we're talking about is how do we industrialize the process. So some of you have seen this as an example, I think, maybe before as well, but I'll build on it a little bit for those that haven't. Conventional design. You design the component as you see in the green space there, right? Well, we start thinking differently. We say, well, instead of designing it from the bottom up with that approach, we know location points, we know keep out areas, we have a rough idea of the load that's going to be applied to this, whether it's rotating, what's happening. We can put in those variables. And with generative design, we could tell the software to design the part for us. The problem is it would create something like this. And you say, well, how the heck do I manufacture that? Right? But now with additive, you think, well, it's not that big a deal now. I can print the part. The other problem, though, is the model I get, how do I modify it? All right, so we've introduced convergent modeling. And if you haven't spent time to see what we're doing with convergent, I really suggest while you're here you take a look at it. And I'll talk about it a little bit more in a moment, some examples of what we're doing. But with convergent modeling, we can model right to the facets. So if you can imagine, this is a faceted triangle-based model. Not just a pretty picture. I can model to it. I can change it. I can tweak it. I can change the way the design's laid out. I can run analytics on it, CAE against it. What's really going to happen with this thing? And I also can print it and machine it in the same device. So for example, DMG Mori has NX CAM embedded into their hybrid machine tools that allow them to print and machine in the same setup what we're doing. So what we're looking at is how do you industrialize this process? It's not just model and print. It's model, run the analytics. By the way, with CD Adapco, we can simulate the flow of the material as it's deposited in this process. We can then look for the residual stresses that build up, the deformation in this, and really understand what it's going to take this additive thing and turn it into an industrial process that we crank out. Back to this idea of generative design. Again, you define a few control points. You can see in the model here, the one in the back, the basic idea maybe is I got control point sweep and keep out this area. Well, you let the software go. Optimize it. Strongest part, lightest weight, design the shape for me. And I end up with a thing in the front. Again, it doesn't have to be a solid model. I can use it with facets, the way it's modeled. The other thing to think about is, even with this approach, is I could scan something. And you know the traditional way we would have dealt with the scan of something is we take that point cloud, we try to put some surfaces through it, we try to stitch those surfaces together, we create a solid model. And as you know, what we introduced with synchronous years ago was the ability to take that model, even though it doesn't have intelligence built into it, to assume the intelligence. It doesn't have to be a feature-based model for us to be able to work with it. That's what synchronous was all about. Well, now we've taken it one step further. We don't even need the solid model. We'll stay with the facets. We'll stay with the scan and work directly from the scan. So think about your design process. I'm not going to start by modeling something from scratch. I'll scan it, I'll tweak it, I'll scan it, run CAE, print it, I'm going. Or I locate a few points, design the part for me. What's interesting about this, you can see the fidelity of this part. What we're finding is some solutions struggle with the quality, and they really don't give you the ability to modify it. You want that part or that part? So while you're here, take some time to look at it. It's really, really interesting technology that we've introduced and leading with the way we deal with components like this. And back to Siemens. We don't just tell you to use this, we use it, right? So in this process, we can do repairs for our Siemens Energy group. It used to take 44 weeks, ship the part back to HQ, they make the changes, update, whatever. Now we're doing it on site with 3D printed parts and doing it in 2 weeks. 44 weeks to 2. So I like to say we eat our own dog food. We're using our products for what we do. Talked about the product, talk a little bit more about the digital factory itself. And really this is, how do you analyze production scenarios? How do you leverage virtual commissioning? How do you monitor it? How do you really optimize the factory? I'll give you an example of what we're doing here. So our production systems engineering solution is really the space where you bring together mechanical engineers, control and systems engineers, software engineers. How do you develop simultaneously in this kind of an environment? Again, where you're bringing together the mechanical, software, and electrical into one environment. Well, we've always had the ability to do virtual commissioning, the prove out of a system. Right, we can do that virtually. But when it came to the PLCs, we still had to have hardware in the loop to prove out the PLCs are interacting with the rest of the digital world that we've built. We've recently introduced PLC Sim. PLC Sim can simulate the PLCs in the same setup. So no more hardware in the loop. We can simulate the entire process exactly as is, taking hardware out and taking the process of this whole idea of virtual commissioning from weeks down to days. And we have customers doing this every day. Changing again the way they think about next practice, not best practice. And then finally back to utilization, this feedback loop. MindSphere is our Internet of Things operating system. What makes us unique with MindSphere? First of all, Siemens has an advantage of all of that equipment that's in those factories. We have 30 million automation sensors, 70 million smart meters, 800,000 connected products that are all Siemens products sitting in factories today. And we can connect to those immediately. That's what MindConnect is all about. We'll connect to other devices as well, but we already built in. We can connect to all of those right away and have a feedback loop back. MindSphere then is the operating system. On the top are the applications that sit on top. An application example, you heard a little bit about, I think during the presentation or the week, Omnio, if you haven't heard about it before. Omnio, for example, Dell, computer uses Omnio, our solution today, for analyzing supply chain information. They're able to analyze 9 billion pieces of information, 9 billion pieces of information in 3 hours to fix a production problem that they had with the product. Previously, it would have taken them 3 weeks to do that, using Omnio, our solution set. Now, the interesting thing about that is Omnio is an app. In the case of Dell, that was prior to us having MindSphere as the IoT platform in place, so they built their own. But that's the point about being open. Our apps will run on platforms that are not always ours, and our platform is going to support apps that aren't always ours. It's an open solution to be able to build against. The advantage, again, is that Siemens has immediate connectivity to all of that stuff sitting in the factory today. An example of this is a customer you have in Germany where they're using this for analytics. Really, it's about condition monitoring, preventive maintenance, the classic things you would think about in an IoT strategy of looking at a factory or looking at a machine tool. But at Siemens, we think about we could do a little bit more. And that is, we say here, MindSphere lets you speak sneaker. What we're saying is sneakers, golf clubs, machines, they all have sensors in them. How do we take that information, again, as I said before, feed it back and make changes to the product? We thought the golf club was going to act this way. Out of the 500,000 we sold, the sensors are telling us, no, it's not acting the way we thought. How do we change that, bring it back? That machine tool I showed you before. Let's suppose you've got 10,000 of those machine tools installed around the world, and you've got a failure happening, and the failure is happening because of a vibration problem. Well, instead of us just coming back and telling you got a vibration problem through IoT, we're going to take the sensor data, actual vibration data, feed it into our 1D analytics tools and 3D analytics tools, and actually run iterations against the real vibration data that's happening in the field. A true feedback loop back. All right, so again, the idea of understand what's happening, how do you bring it back? Why is that important? It's back to what I said a moment ago. The differentiation here is not only will I tell you about preventive maintenance with our solution set, I'm going to work with the products you have as well. It's that idea of ideation, realization, utilization, and representing the product, the production, and what's happening in the field, and then holistically covering it through software, mechanical, electrical. That's what our story is. And there's no one in the marketplace that can do this. It's our differentiation with what we're doing with MindSphere. A few other things. We talk a lot about the product set, but I just want to talk about the things we're doing. When we talk about systems, for example, I've always said systems are very important. A systems design approach is very important, but not at the expense of best-in-class tools. We still have to have the best CAD tools. We still have to have the best data management tools and so forth in what we're doing. And we also have to continue to make them easier to use, easier to deploy, and easier to buy and purchase and work with. And so we've offered a number of SaaS solutions, software as a service. You don't install it, you don't have to worry about monitoring, you don't have to measure, whatever, we run it for you. You come in and use the software as a service. Omnio is one of those examples. Works software as a service. Polarian for application lifecycle management, same thing. You don't have to install it, we'll take care of it. We run it on the back end on our side. It's a cloud-based solution. Teamcenter Rapid Start, same thing. Up and running, you don't have to worry about it. We take care of it for you. And then in our CAE space, we've done this for a long time, is what we do with our solvers, what do we do with some of our applications, again, all based on SaaS solutions. The other that we continue to invest in is small and medium business. Sometimes we're talking about systems engineering, yes, people say, well, that's really good for the gigantic automotive companies, but I'm doing something different. And so we've looked at that and we said, look, what are the things we can do to really have a way to go faster in this space of small and medium business? So here's an example of machine design, engineer to order. Cloud-based solution based on a catalyst, pre-configured, set up to actually go do the work we do within machine design. And if you haven't looked at what we've done with Mechatronics Concept Designer, it's quite interesting as to how you can simulate all this and bring it forward. And finally, how do we make it easier for you to just look at this stuff and evaluate it? If you haven't checked it out, you might want to check out our digital exchange. It allows us to have the ability to learn about our products, explore with them, download it, try it. And frankly, if you want to buy it, you can buy it all online. You never have to talk to anybody. You'll see more and more of that to be able to allow you to evaluate our software. as we go forward. So I'll close it out with this idea of the digital twin. We continue to invest. You've seen the investments we've made. It's really proving out how do we better represent the complex products that are in the field? How do we take advantage of that? And I guess, it's everything from the acquisitions we've made to how do we integrate it and how do we drive it forward. And I would just close with is be the disruptor. Don't be the guy that's having to respond. Be the disruptor, right? Think big and think Siemens. Thank you very much.